Okay, maybe before I start, how many people haven't heard of ESP8266? Okay, that means still about half of people actually knows what it is. Okay, so let's just start straightforward. What I'm talking about actually, why ESP8266 is so popular is because of the Internet of Things. What is my understanding of Internet of Things? That let a coffee pot treat you when the coffee is ready is not Internet of Things. It's not productivity. I'd rather have a beep or a light blinking and tell me it is ready. Also, turning on or off a light, I'd rather get up and find a knob rather than take out my handphone, launch an application, find the switch, and turn it on. I don't think that is Internet of Things. So what I really want to address here first is beware of the overhype. There are so many people crunching into this little space and introduce all kinds of devices, but not much actually makes sense. But to me, what is the good things about Internet of Things is that, firstly, it is remote convenience. For example, I forget to turn off my coffee pot, or I forget to turn off the light when I leave home. Then I want to know what happens here, and is there any fire hazard, everything. Then Internet is very handy because I can remotely monitor what happens. So this is one part of the thing. Or maybe I release a device to my customer, and the device is working, and suddenly it breaks down. I want to do a diagnostics. If the device can connect itself into the Internet, that would be a much, much easier for the supporting staff. So in this circumstance, why not connect your device onto Internet? So we're talking about remote conveniences, mostly is your device can push data onto Internet. But it can also work the other way. The device can get data from Internet. For example, I can have a device that monitoring PSI readings every day. And if it's more than 200, maybe they show me a light in my door when I go out. Did you remember to bring your mask? This is also possible. Or I can have a device that retract my clothes hanger when there's a weather forecast, say it is going to rain in half an hour. So these things also everything can be done through the Internet with a device by itself autonomously without me looking to my handphone. Okay. So where is ESP8266 within the whole scenario of IoT? This is my understanding. It is kind of in the center. And one side of the picture, it is Wi-Fi. ESP8266 is actually a Wi-Fi bridge. And it bridges Wi-Fi signal to all kinds of sensors or actuators, for example, a motor or a relay. And it kind of moving data in and flow from sensors to Internet back to your action unit. And it's also possible to use a mobile device to connect to the ESP8266 directly, or go through all the way from Internet go back, if you are not within the range. So we go forward. So in a nutshell, the chip is developed by Express Systems. They are actually based in Shanghai, but few people actually knows that the company is headed by a Singaporean. And the chip is very low cost, $2 to $3 in single quantity. If you're talking about all the peripherals to be included, it's about at $1 more. It has a 32-bit core processor built in, which is based on a very not well-known Tensilica extensor core. It is not like ARM core, everybody knows. This is a very less known core, but it's actually used in many of the media processors, so it is not completely new in the picture. Of course, the core is not developed by Expressive themselves, but they do develop the RF front end. And they have integrated many of the RF black magic inside the chip so that you don't need many of the outside peripherals or outside components. Later we will see. The chip runs at 80 megahertz or 160 megahertz, depending on the PL settings. You can just imagine your usual Arduino is running at 16 megahertz. This is 5 times faster. And you can imagine like a 15 years ago, we are running a 486 computer at 66 megahertz, which is doing the real-time MPEG word decoder. Yeah, this is actually more than powerful than our old computer. It has an external flash. That means the chip doesn't have a flash by itself. So all the user code actually load from our external flash. This is good or bad. And the good thing is that you can actually using your own flash and you can design how much flash you want to build into the system. You can 4 max, 8 max. It's up to your choice. But the best thing is that because of the flash is external, it is very bad for IP protection. And your competitor maybe just desolder your flash chip and read it and copy it to another chip. So if you really want to solve this problem, you have to look into some of those authentication to the main chip. For example, when you start to run, you read the MAC address from the chip, do some authentication, then if it's passed, then you go ahead. That kind of thing that have to be built in. And the chip has two types of RAM. One is DRAM, and the DRAM is data RAM. Data RAM is kind of it's the RAM we normally think of running the code. The system services like Wi-Fi stacks use about half of the DRAM, so the balance is about 40K that's up to the user to use. So again, compared with Arduino, it's 2K. So this is 40K for a user to use. And there's another 35 KB of iRAM, it's called the instruction RAM. And because of the code actually is in the external flash, when it's running, actually the execution code is loaded from the external flash into the iRAM and executed from the RAM. I point out this out is because this iRAM is actually quite small compared to the flash, so that there's a runtime, some kind of algorithm that read the caching this code data from flash into the iRAM and execute. So there's some of the uncertainties for timing, but you seldom need to worry about that. And as a microcontroller, it has most of the peripherals like an ADC. It's a 10-bit one. It's not very powerful, but it's good enough to monitor, for example, a battery. And it has GPIOs, it has SPI, I2S, DMA. All these are gradually opened by the expressive SDK. And for the part number, it's called ESP8266EX. Many people is asking whether they bought the module. It's actually an EX version. What happens is I never see a ESP8266. It's always EX. And for this chip, it's 25th week 21.4. Okay. As the figure I know recently, it is 20 million chips sold, 5,000 active developers. So with the chip itself, it's not enough actually. So there's some manufacturer making all these kind of modules in different kind of form facts. And within this chip, actually, it is the ESP8266. There's a flash, there's a crystal here, and then an antenna, and some of the miscellaneous passive stuff. Then it makes up the whole running modules. And this is what you can get from AliExpress, Taobao, eBay, whatever. However, it is not. If you really want to use it on into your prototyping systems, you do need a development board. So these are some of the famous ones, the Adafruit, Spark Fun, and this one is particularly like this one. It's a no MCU board. It's quite cheap, and the good thing is that for these chips, you do need an external USB to serial adapter in order to program those chips. But this one has a built-in one. And I have to mention this is not done by me. But I'm not pushing this for the moment. Okay. If you're really going to buy this one from Adafruit, Adafruit not selling this one. You want to buy from AliExpress or from eBay, please do recognize that there's a so-called unauthorized version of this flooding on the internet. Please look carefully. The real one has a bigger regulator, the fake one has a small one. It actually matters a lot, as I will show later. So there are several ways to architect a project with ESP8266. This is the older style, whereby there's a module. This is the very frequent thing, ESP01. And you need an external microcontroller to talk to the module using some AT-like commands. This is the initial release of this module about the first half of last year, and use an Arduino or something other MCUs to talk to the sensors. So everything have to go through this AT command line, and the firmware at the initial stage is not very stable, so that many people complain about crashing or data not sending, whatever, a lot of complaints. And this problem is no more. There's two reasons. One is the AT firmware has been largely improved, and it's very stable now. The other reason is Espressif has opened ESP8266 SDK. And now you are able to program the chip directly, write their own firmware, and you do not need a microcontroller in between. You can get direct connect to all the sensors. If you do not have enough I/O port, use an I/O expander. So I run a quick small demo here. Where's my? Oh, I have to. You can see this one. This is this board. I put here. I have to connect to the chip. So you cannot see this one. It takes a while to. What happens now is actually I use this laptop's Wi-Fi direct connect to the chip on board, and it loads a web page from this chip as well. It takes a while.
So is your laptop an AP or?
Oh, okay. It's the ESP8266 is used as an AP,
Okay,
and the laptop is connecting to this. I didn't give the sound in here. It is actually a spectrum analyzer, and it does the music. Oh, it's a.
You can plug that into your microphone jack, maybe? The other side? Or
I don't know where is it. The line is a little bit. No sound. No sound. Whatever. Later we can play this some more. Yeah, we can play this some more. So it is kind of. You can run in real time. What happens here is actually the web audio API, which Qingmei happen to be presenting this in another room now. It actually read the music and does a spectrum analyze and get all the did a kind of real-time FFT and push the pings. I push this through our WebSocket and go to the ESP8266. So actually, like this is even nicer. That's the light. Okay, we have to go forward. Design using this chip. What does it support? This chip supports and WPA2, WPA, and also OpenX. they claim they can get about like 1,040 kilobytes per second. It is more than enough for many of the applications, but they are actually doing nothing. We just receive the TCP packet and just dump it. But if you want to do some processing of this packet, of course, the speed will be slow. And many people on the internet are asking how much the power do we need to supply to the module. And actually, I met a lot of people. I received a lot of questions after I sell my development bodies. They encounter power problems, so I want to mention this more. And what I did is I actually using this microcurrent to measure the current go into this module. And also I removed the LEDs from the module itself so that the LED doesn't consume any. There's no extra current power being drawn by a LED. So for our idle state, which means if you put the module into sleep mode, the power consumption actually is very low. It's about 40 microamp. However, this is what happens when the wireless is active. What happens is it will consume about 64 milliamps of power at a base level, but in every 100 microseconds, it's a very huge spike of power drawn from the chip. And this is kind of a Wi-Fi handshake signal that you cannot avoid. And because of this 424 milliamps, it causes many of the power supply to fail, especially like a spike, very huge spike of power. And these spikes actually is 847 nanoseconds wide. And you do able to use a big capacitor to try to bypass your power to minimize the spike. But in average, the power consumption is about 66.5 milliamps.
At what voltage is this?
At 3.3. Okay, but just now, this is Wi-Fi idle. That means the Wi-Fi is not sending anything. It just keeps contacting to the AP. Whereas this is active mode. And this graph is I get from the demo. I just using this one. When it is sending WebSocket, there's a lot of spikes, a lot more spikes. But these spikes, because of they are so narrow, the averaging power consumption doesn't increase too much. Actually, 67 point. Just now it's how much is it? 66. Yeah, 67. Not too much increase. So many people thinking about power ESP8266 project using battery, and within this kind of power current draw, you actually cannot power this for too long. So the only chance, if you really want to do a battery power, is to put the module into a sleep mode. Then after a certain time interval, you wake it up, do something, then sleep again. So this is the power consumption where the module, here it is sleeping. Then it start to first run. It do a first. Okay. This is module startup. After startup, they are RF calibration. This is always happens when the module is starting up. This can be disabled, but it doesn't create too much differences. And here to here, this time is actually quite long. It's about 2 seconds. For this period of time, the module is doing scan AP, connect to a DHCP, get all the IP address, everything, about 2 seconds. Then what I'm trying to do here is actually connect to a server, send some packet, then put asleep again. So in this circumstance, the whole process takes about 5.7 seconds, averaging 70.2 milliamp. So if you want to run this using battery power, it's very easy to calculate. 2,500 milliamp lithium battery. Standby runs 7 years. You don't do nothing. Always on 37 hours. If you wake up every 1 minute, is about half a month. But if you wake up every hour, this battery can last for 600 days. And it's even more for 2 alkalines. So this is what you need to know before you go into design this. Your actual management may vary. Okay, but I have to mention that you need to keep your options open. ESP8266 is not the only answer. There's other things, Photon, which is a Wi-Fi module, has some better performance. And if you really want to go low power, like Bluebeam using Bluetooth low energy, which can run on a coin cell. And there's also another type of devices which runs Linux, running on OpenWRT, as it's very cheap. If you really want to have some something like a high performance, you need some more performance like a stream video, then this may be the answer. So ESP8266 is not the answer to all Internet of Things. Okay. What you need to carry on your development, of course, you need a module. You need a USB serial adapter, unless you are using the one made with no MCU, have a built-in USB to serial converter. And please have a very good power supply. And these are good things. Of course, the black power supply is the best, but if you cannot get it, get a power bank or get a reasonable branded wall plug. Don't get those wall plug with selectable voltage like 3, 6, 9, the kind of wall plug that usually is very poorly made. Okay, then I go through very quickly about these are all hardware. This is hardware talk, but I still want to show what are the best way to program this. The best way is Arduino. ESP8266 just some community member just released a toolkit that you can install into the Arduino IDE, and you can select which board you use. And it is compatible with many of the Arduino libraries. And okay, I think I can skip this one. And another choice will be no MCU, which is a scripting language based on Lua. You can download from this one, and actually, if you buy this little no MCU board, it comes inside this chip, and comes with all the Lua interpreters that you can just script the languages. And if you really want to have a very low-level control, then you really need ESP8266 SDK and the toolchain. The SDK is available at this expressive bulletin board. They still call BBS, I don't know why. And the compiler, you can download the compiler from their bulletin board as well. Or there's open source compiler toolchain available. Maybe later I have to make this all available online so that you can just click the links. And there's somebody really put up everything together, all the toolchain, all the utilities, and sample codes, all the SDK together into this unofficial development kit. You just download the file, but it works on Windows only. You just download, install, everything is done. And they even teach you how to use Eclipse as IDE. And for the SDK, there are two types of SDKs expressively given. One is just they call IoT SDK, which is a very low-level SDK. And it's partially open source, not fully open source. It contains some of the libraries which are binary. And it is not like a normal MCU SDK we see. It's just a tap of some of the libraries to control the peripherals. For this SDK, they have some special, very nice features. For example, they have a timer. And what happens is you just arm a timer, give a callback function, and give a time. Then the timer will internally call these callback functions at a certain time. For example, you want to blink a LED, you just do this. You set a timer function called blink. Then it will just maybe for this delay amount of time, it will just turn the LED on and off. So you don't need to run your original style, turn the light on, then delay for how many seconds, then turn off again, then on again. Like that kind of those things are very CPU consuming. This will be much easier. And it supports some of the tasks, something like OS concept, but it is not really our OS. The task is a kind of function that once it starts to run, it's waiting for queue to be enabled, to be fill up, then it starts to process. And you need to touch 2 more. Okay. The network API is something like this. It do all the callbacks. When the user starts, it did init done callback, which is after the system initiation is done, it will execute this callback. So this callback starts and do all the regesting of all the connections. Once something connected, it execute this callback, and this callback go again. It regests some more callbacks. It's a full of callbacks for this for the Express SDK, and the reason I don't like it is because you will get confused very soon because of so many callbacks. It's very hard to navigate within the source code, and also it's very hard to maintain your code, and its documentation is very, very messy. So there's another SDK which is called RTOS SDK. It is also open source, and it is hosted on GitHub, and it has a free RTOS inside. It has BSD socket. It is very clean code. And for this RTOS, it's pretty simple. Everything is a thread. You run a thread. Every thread is a kind of infinite loop, and inside it you just do everything. And after you finish doing something, you just call this v-task delay, and it will automatically switch to other runnable tasks. So I can quickly, do I have time to show another demo?
Is it a clock?
Mm-hmm. Yeah.
We'll try to make sure you're not going to get arrested.
Please. Okay. This is a clock, which is also made of.
Oh no, it's ticking.
It's ticking here. What happens here is there's a ESP8266. It connects to an NTP and get the current time. And it connects to a temperature sensor.
Oh, it's beeping.
There you see what is the current temperature of the room, what is the humidity. And all these data are available, have been pushed onto internet.
That's a remote designation button.
Okay. How do I? All these data have been remotely pushed to an MQTT broker here, and I can send message to here. I can send message to here. And because with RTOS, actually, all the tasks are separate tasks. One task manages the Wi-Fi connections, one task manages reading of the temperature sensor, and one task monitor the MQTT server. So everything can be done within one simple chip. Okay, I think almost done here. Some of the other resources that you need, of course, the official website. The ESP8266.com is a community website, and there's all of the developers actually actively exchanging the idea here. And there's a very useful application called ESP Explorer that you can use to connect to the serial port of the module. And it recognizes what firmware is running inside the module, either AT or no MCU. It has different interface for these for kind of quick presets. And my favorite serial terminal, Termite. I use this because I cannot find a good serial terminal in the Linux, so I have to use this one. And lastly, the Flash download tool, which is used to take your compile the project and use it to download to the chip. Okay. And finally, about me, you can get me from all these places, and mainly my blog site. You can get all the contacts for others. Okay, I think that's all.